So hello, today we are going to discuss at the YakRover um, ways to collaborate for our demo day at the end of the year. So we are talking about some kind of field testing or some game. And for that topic, today is more specifically about what we could do concretely. And so briefly, I have no screen to share, but recently at the YakRover we talked about some kind of application we could do for the demo day. Okay? So, for example, some kind of a distributed game, things like that. Okay, and so to make that real, we are thinking about trying to describe at a high level things we could build. Okay, as a group. And so this week we've discussed offline three topics that we're going to review in a bit more depth today. Okay? So one was presented by Venkatesh, and so I will summarize it as something I call an inter-agent protocol. Okay. So here an agent is either a rover, like a YakRover, uh, maybe a robot that is not moving, okay, like a base station or I don't know, a robot's arm that helps moving things around, and humans. Okay, and so when we have all those agents interacting with each other, um, there is a need to have something in place for to allow them to actually communicate. Okay, and so usually that's called a protocol. That's why this proposal, which is in Discord, okay, I summarize it as an inter-agent protocol. Okay, how to define how agents interact to accomplish something. Second way to sorry, the second aspect has been proposed by Red, which is basically a bottom-up proposal, okay, of a stack, software stack to basically to implement whatever we are talking about. Okay, again for rovers to interact with each other. And so this proposal is on GitHub. Okay, the link is also available on Discord. We will share it later. It's an open discussion. And what is very interesting, that is very practical. It's about reusing well-known technologies, especially web technologies, typically TCP/IP, and on top of that, to allow for the communication between agents. Okay? So it plugs pretty well with the first proposal of inter-agent protocol by Venkatesh. And the last aspect discussed this week, mostly today, okay, is a document on Figma that we shared a bit earlier, which is more about a description on how inside the agent the software could be structured to make our work easier, okay, and maybe possible, okay. And so the basic idea basically is to separate how agents are used, okay. So for example, if we tell to an agent to go forward, okay, how does this agent translate that into real actions? Typically, for rovers, we have rovers with wheels and rovers with legs. Okay? So what forward means concretely for a wheeled rover and for leg rover? What commands does it mean? Okay, and so the Figma proposal is one way to structure the software to make that possible. And so if we implement this such kind of stack, then we can share it in the whole group and interact. Okay? And so to sum up this introduction, we have three points to discuss. And what is very interesting that without any coordination, they are pretty complementary. One is about between inter-agent communication, the one from Venkatesh. Mine is about intra-agent structure. Okay, so how does it happen inside the agents? Okay, here the agent is the robot. Okay, and the last one is a mapping to concrete technologies. Okay, so that the proposal from Red. Okay? And so I found that pretty interesting. And I will end the umbrella introduction here. One proposal now is maybe to, since we have three authors for the three aspects, is maybe to go a little bit deeper in each of the proposal and discuss them further at this point. All good with that? So if so, here's a proposal for the order. If you don't mind, I would propose to start with So in order to have Venkatesh, me, so Venkatesh on inter-agent protocol, me on intra-agent, and then Rhett on mapping to actual technologies. Okay. So why this order is because it's more about the conceptual, okay, to more concrete, hard topics where we can, I think, more easily then follow up by maybe identify some actions we can take for next steps. So it's just a proposal, but if it's okay, Venkatesh, would you talk a little bit more about what I call the inter-agent protocol?
Yeah, I can do that. I'm going to share my screen and show the messages on Discord that I put that in. All right, can you guys see my screen?
Yes.
Okay, so I posted this. It took me like 2 minutes to post after the last meeting. So please don't take this too seriously. It's extremely deeply thought out. It was just off the top of my head thoughts to get the discussion going. So I think in the back of my mind, I was thinking of like, on the one hand, the mission proposals we were talking about last time, like, maybe a race of some type around the world, maybe a cave search and rescue, something like that. So you have like concrete proposals like that. And then what's kind of an interesting sort of technological capability that pushes the envelope a little bit that we can kind of demonstrate through that mission. So you kind of want to have a successful mission as the demo for the year, as well as show off like some kind of new capability that really hasn't been tried before. So this one's kind of in the realm of inter-agent coordination, like you said, and I wanted to ask, what's the most general definition of agent you could use? So it seems to me that there's 3 kinds of agents in the system. One is the actual rovers wandering around wherever, and they can talk to each other and to humans and stuff. Then there's things like base stations, relay transmitters in orbit, something like the Mars, I think it's called the Mars Observer Satellite or whatever. Then it goes to the Deep Space Network, then it goes to NASA. So there's like 6 or 7 types of different nodes before it gets to humans. And then humans interact with the system through a terminal. And normally we think of humans as being outside the system and issuing supervisory commands in sort of God mode. But I think it's actually kind of useful to even think of humans as nodes in the network who share the same sort of protocol structure and constraints. And the reason is the more intelligent and autonomous we make the rovers, the more we should trust their judgment, especially with like time delays to Mars or difficult situations where we may not have, like even on Earth, if it's like a couple of seconds delay, they might still be in a cave somewhere where they have like access to lots of sensor data and processing and may know things that human supervisors won't. So you want a structure within which humans can ask rovers to do things, but rovers can also ask themselves to do things, and rovers can ask each other to do things. And it's not necessarily the case that humans have like dictatorial override authority. So just the kind of example I'm thinking of is the humans trying to do a search and rescue mission, and it's seen like a delayed camera feed where some injured person is sitting somewhere, okay? And he's seen the picture and he gives the command, go rescue that person or something. But another robot has observed that the first robot might have like, a leaky nuclear power pack, and therefore it's dangerous for the first rover to go there. And the first rover doesn't even know it. Might just say yes to the command. So can the second rover ignore what the human said? It said my connection is unstable. Can you all still hear me?
Yes.
Okay. So that's kind of the motivation I'm thinking of, and hopefully that connects up the links between the kinds of like simple mission scenarios we're thinking of and the kind of inter-agent protocol. So within that framework, you want all rovers, command stations, and humans to be sort of at some level of abstraction, equivalent peers in an open network. So that's one piece of the puzzle. Second piece of the puzzle is when you try and ask what kind of messaging protocol between them look like. At one level, we can do something very traditional and standard, something like, rovers understand a command language that says move forward, move backward, open the gripper, turn on camera, this would be a very traditional, 60s, 70s style, like fixed semantic vocabulary that describes the domain in which the rovers operate, and then you kind of have to live within that. But your stuff, Eric, got me thinking along different lines, which is your rovers are detecting sensor data and are like sort of intuiting semantic concepts from the ground up. So if they see a new sensor pattern moving this way and the camera is moving that way, then this is a new situation I'm in, and I'm going to call this a new word. Maybe I'll call it like, widget situation or something. And that word should enter the vocabulary of the entire network, right? So if the robot suddenly invents a term like, I found a new kind of red rock, and therefore grabbing a red rock is a new kind of primitive action, the human should be able to like learn that word and talk about it, right? And depending on how much you share context between two agents in a network, the language should be shareable to that extent. Like, the two spider bots that you guys are working on, they both have 6 legs, and there are certain problems and concepts that only apply to 6 legs. Like, say something like move with a gait that's 3 legs up at a time, right? And the two spiders should be able to share the concept 3x3 gait, even though it doesn't apply to humans, it doesn't apply to maybe wheeled rovers, but that concept should be shared at that level. So the messaging protocol should be able to make use of that, where if spider 1 sees spider 2 doing something dangerous, you can tell spider 2, hey, quickly lift up your 3 legs in this 3-leg gait, right? So that's a message that other rovers in the system will not understand, and humans even may not understand. Like, these rovers may have developed an internal language for efficient communication that humans may not even understand. But to the extent people share domain and world knowledge, language should slowly percolate. And this is kind of like just trying to model human language. Like, on Twitter, we constantly talk. Sometimes a meme comes up, and then people recognize a reference, and people who recognize the reference can communicate with it. I'm trying to think of a good example. Like if I said Oscar slap, if you watched yesterday's Oscar and the big meme sort of thing that blew up, you would understand what I'm talking about, and therefore we can have a conversation about it. But if you didn't, you won't, right? So you want that kind of memetic transmission and change of vocabulary. So to summarize the intent of what I'm talking about here, you want a system that at some level of abstraction has humans, rovers, commands modules, and maybe even like sub-modules that can be independent agents. Like maybe a rover can break up into 2 pieces, and then suddenly each can be an independent agent. So you want anything to be an abstract peer in the network, number one. Number two, you want it to have an evolving, genetically evolving or memetically evolving language based on the real world sensor data and concepts being identified, which means you're sort of assuming machine learning in the loop and so forth. Third, you want actual autonomy. So I'm kind of like listing properties off the top of my head. You want actual autonomy amongst the types of agents where nobody has like dictatorial override authority. So human commands don't necessarily have to be obeyed, which suggests that maybe it should be something like a blockchain economy. Like if I pay you enough, you'll do what I say. If I don't pay you enough, whoever pays most gets obeyed. Or if I give you a command that has a high safety rating, that overrides somebody else's command that has lower safety rating, right? So you want kind of an economy of language, and you want all this to work within a messaging protocol that's maybe like what Rhett is talking about, building on something existing like HTTP, but has the potential to evolve in pretty much organic ways. So think of it as like an open-ended evolutionary language that's being invented by the rover system as it operates, basically. So the more it operates, the more data it sees, the more experiences it has, the richer its language and sort of command ability get. So that's kind of my summary of my comments here, and you can go to the Discord and look at it as well. So yeah, thoughts on that?
Yes, would you have a scope in mind for this year, for example? Because here I understand an overarching view of what it could be, okay? And inside that, would there be a subset that could be like a first target for this year?
So one thing we could try is we could define like a basic predefined vocabulary, and the demo in some way invents a new word. So, like some kind of like new situation is encountered or a new kind of failure mode happens, and one of the rovers sort of detects the situation and comes up with a new term to describe it and maybe broadcasts it over the network. So the simplest version I can think of is a rover coins a new term and broadcasts it like it's on Twitter and says, I have invented a new term XYZ and it means my wheel is broken, something like that, right? And all the other rovers update their lexicons and then start using it in messaging, right? So they can also say something like, all right, my wheel is broken as well, so I'm in XYZ situation. So a simple scenario where a single word is added to the language, that would be my suggestion.
Thank you.
And stop sharing here.
Yeah. So when you talk about evolving languages, it's not clear if you're talking about nouns or verbs or just a particular type of noun, which is a concept. Now, I've two thoughts about this. On the one hand, when you have a system which can add words, basically add patterns, you can simply have a very, very big collection of patterns which have perhaps no value whatsoever. Oh, here's a new concept, moving your left leg and moving your right leg just a little bit less. Wait, another concept. Moving your left leg and moving your right leg a little bit more. So you could quickly generate a lot of concepts, but it doesn't have much value. So unless you have some sort of pruning mechanism which selects which one of these concepts have value in the language, what you might get is just bloat. But on the other hand, one of the advantages perhaps of working in the real world is that things happen slowly. So perhaps you can't get as much bloat as you would in a regular computerized system, which every document it looks at, it could generate 50 concepts. So I guess I'm asking two questions. Question number one, is semantics and grammar of the language you're thinking about fixed? And the only thing that changes is abstractions, new concepts. And the second question I'm asking, it's not a question of governance. It's not who decides what joins a language, but rather what mechanism do you have for making sure that most of what you add will be valuable?
I think the second question is probably easier because there's a straightforward method that you can just borrow from both nature and social media, which is basically an evolutionary fitness environment where it's like, if many rovers find a concept useful over many situations, it gets slowly reinforced. So maybe you can use some sort of reinforcement learning that's in some way inspired by Twitter likes or something. So on Twitter, when a meme is liked by many people and many people start using it themselves, it gets more popular and then it gets more current. And I think that kind of also indirectly gets at least one possible way to answer the first question around semantic grounding and things like that without reliance on top-down governance and something like the French Academy declaring what's the legal meaning of a word or something like that. So sorry, I'm making fun of French here, Eric, but on Twitter.
You're completely true. I mean, that's a problem that is discussed in the country, actually. There are a lot of advantages of doing that, but there is also a lot of, sometimes in France, when there is a new concept, like a tweet, okay, we have no way to deal with concepts like that. It will take a decade before we have that in the dictionary. And if it's not in the dictionary, we can't use it kind of officially, right? So, sorry, that's true. That's very true.
Yeah. And if you think about how places like Twitter solve the problem, it literally is almost like a blockchain kind of way. Like a new meme comes up and lots of people use it in slightly different ways. Some people misunderstand it, some people understand it, and a sort of rough consensus evolves around what it actually means. And by the way, a good, extremely atomic example of this is emoji, right? They're as small as you can get, and it takes a while. Like, for example, the top-down version of like this emoji with like two hands. Initially, it was actually a high five. Like if you actually notice, there's like radiating lines that suggest it's a high five because some American thought of it, but most people around the world see it as praying hands, so it acquired the meaning of praying hands. And I think future update to that emoji made it praying hands, so now it's praying hands. Another example is there's a emoji that looked to me like just a silly grin, but consensus eventually decided that it's like gritted teeth. And that's because it's like a cartoon. It's hard to interpret what it actually looks like, right? So what you can do is, first of all, at the top level of abstraction, you allow multiple meanings for a concept to thrive. So there's like two levels of selection going on. One level, only the fittest terms survive as useful. And then in the second level, within terms that are actually fit and useful and many people want to use them, only ones where a reasonable consensus evolves is actually useful, because if like it's being used hundreds of times, but each time it's used differently by different rover, then it's not actually useful for communication. So I think that gives us our research problem. It's like, all right, it's easy to define two levels of selection. The question is, how do you get a ground truth loop that kind of like reinforces the selection fitness? Like at one rover level, you can say this particular sensor pattern refers to like XYZ new concept. But how do, like if your rover tells my rover that this sensor pattern is the word XYZ, how do I sort of correlate it to my own sensory experiences, notice that that's also a similar cluster and say, hey, I should use the same word to describe the problem with my wheel, right? So this is a research problem, in my opinion, that's worth solving.
Let me contract your research problem into a simpler question. My rover tells Eric's rover, please move forward for a glog and then take a sample. Okay, how does Eric's rover understand what a glog is? Do I tell it, or like on Twitter, it's supposed to figure it out? So we don't even have to ask the big question. We can ask the little question. If one rover invents a new concept, how does a different rover understand that concept? I don't care if correctly or incorrectly, but it has to deal with it somehow.
Yeah, I like that. And I think we can incorporate that level of simple challenge in the mission design. Like this is basically a unit of measure that is undefined. So I say move forward one glog. So you have to come to a consensus of, maybe we can actually do this with the two rovers using different measurement systems. One uses inch and another uses metric, and then they don't know it, but you could even say one is announcing its distance as a meter and has to communicate with the other. So yeah, I like that. So some version of that I think would make a good part of the demo.
Okay, so
by the way, so sorry, just that in Venkatesh, in what you presented earlier, you used the term mimetic transmission. Isn't it about that actually?
Yeah, so mimesis in the Rene Girard sense, basically. So you just, it's at a behavioral level. Mimesis, for those of you who haven't like followed that discourse online, is basically people want what other want. So Rene Girard came up with the whole sort of philosophy theory of this is how human motivation works. So in the rover case, it would be something like if one rover decides to go find a rock and gets praised for discovering a new type of rock, all the other rovers will want to go discover rock. So they'll copy behaviors that or let me put it this way, they will imitate desires. So that's what mimesis is. So that's one basis for developing a shared language. We develop shared language around copying desires. You can extend that to copying beliefs and intentions as well. Yeah, sorry.
And there is also, so it's related to Maya's question. Huh? There is also the parallel with is it Dawkins on the memes? Okay, and so it's something that I think is pretty low level actually, and that actually implicitly we're talking about. Okay, is that if a new concepts come in, like Mayer mentioned, I didn't get the word, but is it a made up word of a glow? Is a glow?
Yeah.
Okay. Okay. Let's say we have a new term like that. Okay. I don't know. I guess it happened to several of you to be in that situation. Okay. And for me, I'm a non-native English. Sometimes, I will speak with some native Australian, and they will use some kind of, I don't know. They're always saying "far out." Okay. And at the beginning, I was thinking, do I take it literally, or should I understand something else? Okay. And so, how do I deal with that basically? Okay. At the beginning, there is a bit of puzzlement. It means internally, I don't have a model of what far out means. Okay. And by accumulating experience, okay, by having my host saying far out 20 times a day for 10 days, I do have a model at the end of what I can expect with that expression. Okay, so it's linked to meme. So the meme, as Dawkins used to describe genes, okay, not to describe genes, in relation to genes, okay. There is a mimetic transmission that Venkatesh talked about, okay, and other things we've been talking about over the past year, okay. They don't come back, but just wanted to say that it's pretty linked.
So I may have misunderstood you earlier when you said mimetic, because I was thinking of both memes in the Dawkins sense and mimesis in the Rene Girard sense, and I think both are relevant here. And I think another thing that's relevant here is how babies learn. So many of your parents, and you know this better than me, but from what I understand, children don't learn meanings of words by sort of being told the definitions of the words. They just try to use it while speaking, and sometimes they use it incorrectly, and eventually they narrow it down. Like one example I saw in Stephen A. Pinker's Language Instinct was something like a child that's first seen a dog as its first animal might see a cow and say doggy. And it's because it's like invalidly extrapolating that it's also a four-legged animal. But at some point, the child will learn to abstract and say there is a concept called animal, and cow and dog are like instances of that. But there's something there that I think can be used as the basis for language evolution. Like you infer by context some sort of limited understanding of what the other person is trying to say, and eventually you get it right, or maybe you never get it right, but it's useful enough and you can still communicate. But yeah, that's all I had on my
just 1 second, but you were assuming that the globe was a unit of distance.
Yep.
Okay, like meter, kilometer, but it could have been a different type of unit of distance. For example, a mile marker. So move forward one curve in the road.
Yep.
Okay. And you don't know that. But it could also be something that is not a measurement of distance at all. It could be a color. Now, in the grammar of English and also of Chinese, I understand, we have these signifiers which help us understand what the word is. So this leads back to the first question: what kind of change can be made in the language? Because the real change we want to make is that when the rover moves, there's a new concept of a quality of the motion that I'm trying to communicate. Okay. And I remember I asked the first question was, is semantics and grammar of the language, is they fixed, and all you're doing is generating new concepts? Are you generating also new verbs, or maybe also new language structures?
So again, to take your sort of thoughts in order, what you just did to me is an example of a protocol the rovers could themselves use. Like, I misunderstood what you meant by glog, and I interpreted it to mean a unit of measure, and you just expanded the possibilities that it could be like, a different notion of motion, so to speak. Now, in the real world, if the rovers are acting in a feedback loop, and one rover tells the other move forward another glog, and the other one gets it wrong by moving forward one of its native unit of measure, and keeps trial and error, and eventually the first rover, either coincidentally or not, agrees that the second rover did what it was asked and says good job and thumbs up. But then the meaning only gets tested by trial and error enough times, then they agree that we at least are behaviorally consistent. So there's that possibility that you can have feedback between agents as a way to correct understandings. But the second part of is the grammar fixed or not, or is it something like a fixed grammar defined by a sort of messaging packet, structure or something? Honestly, I don't know. I suspect it would be simpler to start by not having too many moving parts and starting with something with where the scope of the learning is relatively fixed. Like maybe it's a somewhat fixed grammar and you only learn like, I don't know, verbal feedback loops within it or something, or verb-based feedback loops. But again, this is why this is an interesting research problem. We very quickly run into questions we can't answer.
Do you think that we can define a task that we can demo as that shows how one rover learned from the behavior of another rover? Do you
I
think that's
think we could.
doable
We
in a
just have
year?
to simplify it enough. I think we could, like within the context of whatever scenario we come up with. I think we can find something extremely simple where it's at least simply demonstrated.
So I should have a demo of that in a month or two, basically. So what I showed last time with my 3D environment strange thing, okay? The idea is to put two of them side by side, okay? One it's the representation I was showing the other day is an internal representation of a rover or an agent, let's say, okay? And so the idea is to put two side by side, okay? And having them communicate in some way, okay? And it's exactly what we're talking about, which makes it very interesting, okay? And the thing that one of the experiments I'm trying to do is to have them agree on a concept. So, for example, a cup or whatever, something that their sensor can sense, okay? And to show that the two internal representations can be very different, but still represent the same object. Okay, so let's say the cup for one of the agent is represented internally as a sphere, and for the other one is represented as a square. Okay. Still, when they communicate, they will do this mapping dynamically. Okay. Oh, we're talking about the cup, so for me it's a sphere, and the other one will say, oh, we're talking about the cup. Yeah, sure. For me it's a square. Okay. And the thing that I think is pretty easy to see that it's. That I think it will just work, okay? But the benefit of that is that then we can do things like what we're talking about today, okay? Where we can really separate the internal representation, so how it's encoded inside us, okay, or inside the rover, and how we communicate about it. And my goal is to build software to make that possible among different rovers. Okay? So yes. So on the experience suggested by Venkatesh, actually I may provide something quite in line in a couple months, basically.
We should probably move on to the second segment since we're already at 9:40.
Yes, sorry, just a quick one is on inter-agent protocol. There is something that that plagued many past trials to similar technologies, okay? Because they do exist, by the way. We didn't discuss related work, but there are some, okay? It may be a session in the future. So one problem is that, look, let's say that we have, a bulb, okay? A lamp, and we want to change the bulb, okay? And so we want to tell the rover, the agent, whatever, okay? Or another human being, okay, go change the bulb, okay? And I think we want to say that. So the protocol is to say, yes, just change the bulb. After how you do it, it's just your internal planning, okay? But is the protocol about that? Do we want to specify, okay, change the bulb? Or do we want to say to only have messages like lift your body 1 meter, lift your leg, your left leg, lift your right leg. So what I'm talking about for people in software is that do we want something that is action driven or that is remote procedure call? Okay. Remote procedure call is when we tell the target what to do, what action to take. Okay. And so it's the RPC in the software world, okay? And in fact, you know, a lot of things are actually RPC, okay? It seems to me that a ROS is a lot of that as well, for example, okay? It's not good or bad. It's just to clarify what we're talking about, okay? So in an RPC fashion, to change the bulb, I will basically, it's a remote control, basically, okay? I have to tell, I do the planning for the robot and I tell it what action to take, okay? And the other approach is to say, no, I just give you the goal. After how you do it, it's not my problem. Okay? And so there is a trade-off between these two kind of approaches usually, okay? It seems to me we are talking about goal-driven, okay? To say, okay, go change the bulb. After how you do it, it's your problem, okay? So if so, I think it's something we should keep in mind, okay? Because that will affect how we design the protocol in the first place, okay? Put that way, is there any reaction to such kind of view?
I think this actually fits into what Rhett's been talking about, because if you want to go bottom up from existing protocols, this reminds me of CSS. Like CSS is a declarative language. You don't tell the browser how to render the page. You just give it like a style sheet that has like declarations, and some version of that gets rendered, but you don't have control over like execution at a procedural level. So that's the connection that occurred to me.
I mean, I think there's very practical rover-based examples that like I've already been through, where like the very first version of setting commands was like set motor A to full power, set motor B to full reverse, as opposed to like the goal was actually spin right, as opposed to like tell exactly each component what it's supposed to be doing. Now, whether there's a path that says, oh, you can actually learn what these behaviors are, or more complex goals, I think is interesting. But it's maybe that we need all of them to be able to actually accomplish anything. Like we need to be able to directly speak to a component. We also need to be able to define goals. And maybe if you speak component language long enough, you can learn how to do larger goals.
Yes. Yeah. Do we see a relationship between both? Like RPC is more primitive, and we can build the declarative approach on top of RPC. What I mean is that RPC is typically to say, okay, lift your leg, go forward, go back, okay? And so it's really primitive commands, basically. I do the planning and I tell you what to do. And it looks more primitive, so lower level. And on top of that, to have a declarative approach here is to say, okay, go change the bulb. And so I'm not quite sure, because in terms of protocol, I'm not sure there is a relationship, okay?
I think the important relationship is like less RPC and more like request response. Like if you think of it in terms of, I'm going to send a request to change the light bulb, and the response is like, success, I did it. That may seem more like, imperative RPC based of like, here's a request, you succeed, you did it. I think maybe we don't want to do that so much. We want to do more like, please change the light bulb, and we actually don't know whether the goal got accomplished based on that request. Like we're going to have to infer that from other stuff, because it may not happen right away. It may not like know how to do it now, but it knows how to do it later. And I think that, like, how do you think about error responses, or like, no, I just don't want to do it. I don't want to do it right now. Like, got to leave room for the rover to make its own choices.
Yes, and that's a very important point. That maybe what we really want is, okay, is just to say change the bulb, okay? But in practice, there is all the error handling to do. But also, if the rover is changing the bulb, or the robot is changing the bulb, and in the middle there is a problem, okay? Maybe this is where we need to open the box and go at the RPC, or I don't know how to call it, to say, oh, you're going to fall, so you should move your leg a bit to the left. Okay? So this is where maybe there is maybe the right answer is to say we need both, okay? And maybe the question is in which order? Maybe starting with primitive and RPC is more like maybe then in a few months we can start doing in how to say, across the team. Okay, we can start doing something like remote controls. Okay, like we already have, but maybe in a more principled way that we all share. And on top of that, building the goal-driven, the declarative approach.
Start layering higher levels of abstraction on top of it.
I'm
And like,
waiting.
yeah, you may get to a higher level goal, and then eventually you get to, could you please do that whenever you get time? And maybe the rover decides to do it, maybe not. Kind of gives more of that, I think, looser interactions that Venkatesh was referring to.
I'm waiting for Victor to come back because we were working on that. You know,
Yes.
with some type of RPC, but maybe that you can present your view, you know, as a background. I mean, Eric said it's similar to what Ved is talking about, but maybe you could, you know, present it.
Yeah. Do you want me to just walk through the doc that I put up there?
Yes.
Yeah.
I always have the wrong Yak collective in here. So the idea, a lot of this is kind of a formalization, and not even really strict formalization, of what I think some of us have kind of already been doing to some extent. Like, and I didn't go too much into the like how you would structure code on a rover itself, but just more of how the RPC mechanisms, or there we go, use RPC again, the communication mechanisms, however though they may be, could interact, and just relying on technology that at least I think most of us are familiar with, like web servers and REST APIs and that kind of stuff. So first off, I've suggested that we use a VPN, which is something that I know Victor kind of started off, but without him being around to kind of help us get all that set up, I'm suggesting we use what I've been using on my rovers, which is called Tailscale, which is just a managed WireGuard VPN. It's super easy to install and is free for individuals and even like open source projects for groups. And so the idea is you've got a nice web interface and you can grant essentially access to any node in your own private network that you've got configured. And so we can just grant access to each of our rovers as we see fit to whoever we want to be able to access it. And so that enables rover to rover communication or rover to any kind of node communication. And it would be very easy to get that going, but it's also easy to replace with something else if we decided to. You can imagine if rovers were actually interacting in proximity and we're on some sort of mesh network, you know, some VPN may not even be necessary. It's just, you know, they can use whatever networking is available. So that was the VPN, and then the API was really just kind of deciding on some common resources and some common protocols from a REST API perspective. And the only things that I specified in here are being able to post commands. That's just coming up with the name CI, which is something I came across in some of the NASA GPL software. And then it's pretty flexible because you're using, you know, JSON to format whatever your requests you want. And from a very practical perspective, we can get this going with like you can use curl, for example, from the command line to communicate with a rover and send a command to it. You don't have to have a fancy web interface right away, and so it makes, you know, debugging very easy, exploration very easy. And then you can kind of layer on top of that. So at some point you can have a full featured web application hosted somewhere that's acting as mission control or whatever kind of interfaces we want to have. And then I don't know if any of us have really tried this. I did have on my rover, I have a web server that is serving up the most recent image that had been downloaded, and that was how I got the image kind of off of the ground station for display. And so you can imagine it being helpful to have specific resources available with a kind of a REST-based terminology, where if you have multiple cameras or you have multiple other things, you can just retrieve those as an HTTP request, get whatever the device is, whatever the resource is. So in this example, maybe you have multiple cameras, and so you can just retrieve a snapshot for whatever camera you want. And then finally, on my rover, I found it very helpful to be able to just have available as many metrics and as many kind of diagnostic information as I can. So relying on kind of off-the-shelf metric collection type systems that one would want to run on the rover, and then being able to collect that remotely via the kind of a similar interface. That's actually a little bit different than how I had done it on the Stubborn rover, because on the Stubborn rover, I've actually had a metric system running on a whole different computer. And so my rover would like send metrics and send log data to that remote host. But like, if you wanted to have kind of a more decentralized peer-to-peer kind of way to think about it, it really needs to be more of a pull type model where any rover or any node in the system can retrieve whatever metrics or whatever log events or whatever it wants from a rover kind of on demand, as opposed to like configuring itself ahead of time to say, hey, send me all the data that you're gathering. Instead, you would request the data whenever you want it. And then I did mention down here at the bottom that not everything is a rover, and so but that the system kind of works fine. Like you can have another web server that's running on a fixed like ground station, for example, and it can implement kind of similar whatever resources kind of make sense for it. Yeah.
Can we drill down on the post command injection?
Yeah.
Because that's related as RPC. It's not it's less interactive than an RPC, I think, isn't it?
Yeah. So I had found that like for my own command system, basically saying that you received a command was enough. So this command, like it could be a JSON document, right? And I just put in here, oh, you've got a command field, and that is, for example, forward 100 or something. And that's the most like non-specified protocol we could have, I guess. And then the response, though, is simply like, I understand what you mean. Like you get a response that comes back that says, I understand you want me to work. I recognize the language that you're sending me. You get a 200 response. And then what we do with the rest of it, I think, is a little bit left up for debate. Like moving 400, moving forward 100. Like, what does that mean? Is that 100 seconds? Is that 100 speed? Is that 100 like whatever? And that depends on the language. But we know that it's going to take time for these things to happen. Unlike a typical web application, like you're not trying to do it as fast as possible. So some of these commands are going to impact time in the future, and so you're not going to want to just wait for 5 minutes, 10 minutes, 24 hours to get your response back that like, yes, I accomplished the thing that you wanted.
It's basically the link with the proposal from Venkatesh, I believe, with the protocol. This command injection. It looks like a here, basically, and not a here, an ear. We either tell the endpoint, lift your leg, or go change the bulb, and after it gets interpreted in a principled way, okay, at the interface. After how it's done inside, it's rover dependent, right?
Yeah, and it could evolve.
Yes. Yeah.
So one of the new things I think this brings in your point about like your rover has the last image taken by the camera available to retrieve by a call. This reminds me of Meyer's original idea, like when we started, of rovers being social in a particular way, of being able to borrow each other's capabilities. So that's a dimension that kind of messes up a normal way of thinking about language, because normally language is like sealed off from like physical capabilities at a like hardware and abstraction level. Like I can ask you, what do you see? And you can say, I can see a cat, but I can't literally burrow into your head and like borrow your eyes for 5 minutes. So normal language has evolved with that kind of separation, but there's no reason we need to respect that constraint. So we should kind of like leave at least the door open where it's like, all right, this other rover, the processor has screwed up, or like it has otherwise gotten corrupted, but there's no reason it can't be a zombie robot controlled by another robot. So there should be like some sort of like fallback where you can almost like, how do I put it? Digitally scavenge it. Like literally, physically, the rover is like fine, but it's not functional for some reason. So one other rover borrows its camera, another rover borrows its wheels. So that should be possible. And also at a more non-scavengy level, you should be able to like exchange messages of like, all right, I'm done RPCing or like giving you semantic level commands. Let me just borrow your camera for like 5 minutes and take over, something like that, right? So kind of want to like plant a seed of that somewhere here.
Yeah, I think that's yeah, I think that would be an important capability to be able to offer. I think though that there is still a level of abstraction that the like what is built into the API is different than the low level components that are happening on the rover. Like if there's not an API built for it, you can't do it. So for example, pure like just run this CPU intensive task, unless you have decided on a way to communicate that task in between rovers, like there's no, like you can't just SSH in, download some software, compile it, and run it on someone else's rover. Well, unless you build that as an API, right? The idea would be you're not necessarily poking into someone's head and getting their most internal state. It's like, here are the things that I know how to tell you in a language that we're both going to understand, and those are the things that kind of are available in that API. But they're machines, so they can talk at different levels of abstractions than we're capable of. You can upload a model.
In terms of basic API, do you think that maybe just V1 and V1 CI could be just enough, in the sense that access to cams and access to metrics could be instances of command injections, basically?
Possibly. That does move more towards, I guess, classically how you think about RPC designs, as opposed to.
So it's RPC design, but as you mentioned earlier, it doesn't need to be it doesn't need to be synchronous, because we don't know how command injection is implemented. If it's implemented in an RPC manner because the rover is not very intelligent, not very autonomous, well, yes, okay, it's a remote control. But if behind the command injection, basically it's inside command injection, basically there is a whole language, okay? That's the protocol of Venkatesh, okay? And so one of them could be, okay, tell me what you know about imagery, or about your camps, whatever, or how many camps you have, okay? Or tell me about your metrics, okay? Instead of having a dedicated endpoint, it could be inside that endpoint as part of the protocol. That an endpoint is not only the definition of a verb and parameters, basically. It's also definition of the protocol behind it, right?
I see what you mean, yeah.
The motivation for me is to minimize. If I map that in the protocol, we discussed about agents, about rovers and humans. Okay, so let's apply this API to a human. Okay, so the first one, get v1, is a top-level resource to identifying. Yeah, we do have that. Is that if I look at my mayor, I know it's mayor. Okay, it's the identification endpoint. But after basically, it's everything is through the ears, basically, kind of. Okay, it's the command injection is I'm asking someone to go change the bulb. Okay, or I'm asking someone, okay, what do you see? Okay, and I'm asking, say, how do you feel? Send me your metrics, basically. Okay, so it's just for the uniformity across the different agents we're talking about: rovers, non-roving, and humans.
You could very well have like a fusion of the concepts as well. Like you could say, do you have any pictures or do you have any cameras? And the response is actually, here are the URLs that one would visit to retrieve the image from those cameras, or whatever else the resource is.
Yes.
So like the bare minimum implementation of the API might be this like, post v1/CY, or maybe it's just post/v1. And then you could start interrogating at that point, like, hey, who are you? What can you do? Do you have any cameras? Do you have any metrics? Can you move forward?
I think the visual system would be a good narrowing of the demo domain, including for the language problem we were talking about before. Like we could come up with like, instead of move forward one glog, we can come up with a similar low-level concept in image recognition or something like, pick up the glog. And a glog refers to some segmented piece in the visual field. And since everybody is like exchanging images all around at both raw level and like semantic levels, it forms like a fairly good closed domain where we can like work out some basics more easily than in like motion. I think is more complex than vision, and vision also lends itself to like we can do CNNs and do some deep learning and stuff like that in it.
Yeah, but motion is rover specific.
Oh,
and images you can also do on CCTV system. That's why motion is more interesting. Yeah, it's more difficult, also more interesting. Maybe you can contract it some other way.
Yes,
but it would be hard to do this. Oh, sorry, go ahead.
Oh, sorry. I just wanted to link that to something that Venkatesh shared last week about the blind robot walks. Okay, it's this robot that can. It was a 2-minute papers. Okay, it is a robot that learns to walk without camera. Okay, so without computer vision, just by a proprioceptive feedback. Okay, so knowing where the body is and measure progress, and the robot can also, on top of that, can take imagery, so computer vision as input, and do much better. Okay, that's all.
This would be difficult to do with rovers that are not together, but one way to kind of get to what original proposal would be like if two rovers can decide from two different vantage points can identify the same object and communicate about that object without any other, like it doesn't need to be a classifier that says, I see a bicycle. It can simply be, here's an object. It is object, some sort of long hex string, like for all we care, right? They're machines talking to each other. And if they can agree on what that object is and navigate towards it or something, that would be a good demonstration of that. But I don't know how we do that remotely.
I think that's actually a very good demo concept. Like we can have an object that has two handles and literally can only be lifted if two robots cooperate and each one lifts one handle. And the mission can be something like, step one, you're both coming at it from different angles, and you first have to agree that you're even talking about the same object and it's not in your library of mental images. Then you have to agree on what it means to move towards it with like, shared motion primitives. And then you have to recognize each other. Like, if it's two spiders, this brings up the mirror problem we were talking about before. Like, it's like literally on the API and over the network, messages are coming to you in some symbolic language. And in your visual field, there's another rover. it's not actually that trivial to figure out which rover is the one actually talking to you. So you can say something like, all right, blink your red LED 3 times, and then I'll know it's you. And then you sort of map your abstract agent you're talking to the visually visible agent that you can see, and then you know how to coordinate with that agent to pick up the object, right? So lots of complexity, even in the simple scenario of like picking up an object together.
So maybe we could flip that, and a problem which doesn't exist but is remote, I can recognize you from the video streams that you're sending. In other words, if I told you look left and right, and I see that your video stream moved left and right, I know it's you. Okay, now it doesn't exist because usually a video stream will have an ID associated. But perhaps the video stream, I'm not going to try to invent the problem. But instead of saying, I look at another rover and see how it acts, which is interesting, but we can't actually do it. Each one of us has one rover except for Eric. But I can definitely get a stream from Vet and another one from Venkatesh and another one from Eric and tell the rovers to do something. And I can see what's happening in the stream, and I know which one of them is doing what I asked them to do. So that's a problem we could look at. But I don't know if somebody looking at it from the outside would be interested, because like I said, you can always just get the ID. The blinking light problem, of course, is different.
So one way to do a distributed version that also has physical and visual elements is suppose we have like 6 rovers around the world forming a 3x2 grid. So it's like a jigsaw puzzle. And each of the physical locations has a jigsaw puzzle piece, and it has to be placed at a particular location. So I have to place my jigsaw puzzle piece in the southwest corner, and the next neighbor over has to place it in the northwest corner, and the two line up. So the mission becomes something like coordinate enough of a language that you can actually assemble the picture together in the composite feed. So I think we can invent a good problem in this broad space we are starting to identify.
What if you had some sort of a remote bingo where a rover goes around whatever area we've set up for it, identifies a certain number of QR codes or something, remembers them and where they are. Another rover decides to be the bingo master and pulls out, please go to this if you have it. And all the rovers that happen to have that particular object or that particular QR code can go and find it and mark it, just sit there. I don't know.
I'm sure you meant to say NFT.
I did not. I will not.
Okay, but I got to say you're moving me on a tangent. This is basically a rover game that the rovers are playing with each other.
Exactly. Yeah.
Okay, so let's call it rover bingo. In a sense, or maybe rover I spy. Okay, similar concept. I have something, you go looking for it. Whoever finds it first gets there first, whatever.
And then they can, and then the problem with the bingo concept is you've got one leader, right, that's calling out the things, and it would be better to have like the role migrates around. So whoever gets there first gets to be the person, gets to be the rover that chooses the next move.
It's like a game of tag.
Yep.
And I think just not NFT and not barcode, simply something in your environment. Okay, I call out book, and now everybody's rover has to find the book. Whoever finds the book will call out chair or whatever. So, but my question is, and the reason why I'm saying it's a tangent, rovers playing games, that's interesting. Well, why do they play games? And don't say because we told them to.
We asked them nicely.
No, but the thing that it could be a game where we are involved. Okay, that's a link with the protocol that involves humans. Okay, it's a game where, in fact, most of the video games today are a human and an artificial player, right? And so it's an extension of that idea with a physical player, a physical rover.
But we
So
can
why do
have
they just because they are part of the game? That's all.
we can have them playing the game in order to transfer concepts one to another. Okay, so I'm saying the first one who finds a glove, okay, and now they have to figure out what a glove is, so we can play what's it called, the hot cold, getting warm, now getting cold. So, in other
Yeah.
words, perhaps having rovers playing games with each other as a mechanism for rovers learning new concepts, like Venkatesh's kittens. Okay, so that could be something interesting, perhaps.
Yes, and with a little twist, is that to ground what they learn, to align what they learn with the human concepts, is that our role is to initiate it. Is to say apple, for example, okay, and we play with one rover, okay, to know what the apple is, okay, and once that rover acquires it, then it will play with other rovers. And basically, the game is for all rovers to agree on what an apple is, basically. What's important is to ground it in something we can understand. Otherwise, we can end up with stuff that converge, but we're unable to know that it converged.
Okay, so,
Because
what you're saying is we have a chain of transmission. I play with my rover until it figures out what an apple is and what an orange is. And then my rover plays with Svet's rover, or simultaneously with 5 rovers, and they try to figure out what an apple is.
Yes. So yes, what I'm saying is that I think the mechanisms underlying what you're talking about are pretty generic. But for us, human, to be able to be part of that, we need to ground the concept they are learning in.
Yeah.
Yes. Yeah.
I'm just looking at it in the opposite direction. I'm not looking at it as we need the human to ground, because that I could do by programming, but rather I'm saying this is a transmission of knowledge using game playing. And it's starting with the source of knowledge, which right now you think needs to be you, but tomorrow I guarantee that my rover will be much smarter than you and will be able to start the game. You'll have to figure out what a glove is. The rover will tell you.
There is another thing. I don't want the meeting to be too long. It's already an hour and 50 minutes. But there is another thing where the human grounding may be important. Is because, look, if we take an apple tree, okay, for us, the apple is really the salient feature of the apple tree because we eat it. But the rover is not going to eat it. So why would they care about distinguish the apple from the tree? Okay. In fact, we do that quite often. Okay, that especially if we look at children. Okay, and but adults too. Okay, that if there is something I'm not very interested in. Okay, I don't know. For example, I had all my news were about Will Smith. Okay, slapping someone. Okay. I'm not looking into that. Okay, so I don't know the people, or I just have vague ideas, so I don't know the detail. Okay, I just know it's an event. Okay, and for me that's enough. Okay, but if I was really interested into it, I would know every part of it. Okay, I would make the distinction between the apple tree and the apple. Okay, because for example, I like very much Will Smith. Let's say. Okay, and so I would look more into all the detail around that. Okay. So it's in this sense that if there is no human grounding, okay, we may end up with situations that maybe are correct in terms of whatever mechanism we've implemented. They converge, but we are unable to interpret them. by themselves, I don't see rovers. I don't see how they would get motivated to distinguish the apple from the tree, just because they don't care about either. In a way, they don't care about splitting that information.
Someone
here
would
I
have to
think
tell
you're
them they
right.
did a good job.
Sorry?
Someone would have to tell them they did a good job
Yes.
so that they can receive, applause.
So I think the way to do that within the framework of a network where humans are peers with rovers is basically economic. Like rovers will learn to care about what an apple is if humans pay them, on the rover blockchain for discovering apples. And you can actually make this more realistic with like Mars exploration or something. Like maybe we care about finding water on Mars, and there's maybe chemical signs of water on Mars, and particular shade of red rock indicates water. So finding that is like finding apples, and you pay the rovers for that, so they learn to care for that. So that's one way they can learn to care. But the other way is it's existentially important to their own survival, so they'll care whether or not somebody else is paying them. So rovers might find certain rocks to be dangerous for their legs or wheels. It can hurt them. So they learn to identify that as a threat and give it a name and so forth. And humans may not care about that, right? So we should leave the door open for both kinds of concepts to emerge. One concept you're paid to learn, or you play to learn, or for some other incentive scheme, you sort of learn for extrinsic reasons. And another class of concepts you learn for intrinsic reasons, for your own sort of fundamental utility function or survival function.
Yeah. So I think those mechanisms are relevant, but it seems to me that maybe they're not even necessary, because if the mechanism involves humans, okay, humans care about the apple, so they will use the concept, they will single out the concept. So that would provide signal to the rover, and so maybe they don't care for themselves, but they will have to deal with that concept because it will appear. This is where the interaction protocol really plays into the development of the minds, basically. Okay, it's an example for that is basically if you take the apple and you show that you take the apple tree and you show that to a young child, okay, and look, an apple tree. When I say that, internally I think, because they are nice apples on it, I want to eat them. But the child doesn't know that. The child just see me saying, there is an apple tree. So the child, step by step, learns, an apple tree. My father is happy there is an apple tree. Okay? Until the day where I pick an apple from the tree and say, look, you can eat it. And then the meaning of the apple and of the apple tree change for the child. Okay, and it's something that is interactive without. I don't see any need for something like a blockchain or any utilitarian motivator to single out this concept.
From my experience is the opposite. They don't care what kind of tree it is, but when you carry them up to the apple tree and they can pick an apple, then they care that it's a tree with things you can pull off. And when they actually take a bite out of the apple, then they care that this is an apple tree and that's an orange tree. So at least from my experience, children, unless they have direct meaning for all of these fuzzy words, they don't care if it's an apple tree or a mango tree or any other.
But the thing, so that's a good point. Is that basically, I think there is no difference between what you say and what I wanted to say. However, what you suggest is that there is a different kind of experience. Okay, the point is that the child experiences the apple tree in a different way, in a more precise way, and maybe by accident. The point is that will change the perception when I will talk about the apple tree. That agent, that child, will not interpret it the same way anymore after that experience. Okay, so it's just, I think it's very compatible with what I said, but just a different route on how the child perception changes over time, without blockchain, without utilitarian model. Sorry, we are already 1 hour 20 minutes, and I still have my document to go through. But in fact, we've already talked. Maybe just, if you don't mind, a couple minutes we look at it, just what it is about, okay? Because now it's online and we can interact on it later on. Okay, I'm not sure it brings too much more to the discussion today. Are you okay to switch to it? Just maybe less than 5 minutes, so that after it's maybe we can stop for the day, perhaps.
Be warned,
So-
you're going to talk, but we won't have time to comment.
I know with the comments too. After it depends. Personally, I have time. Okay, it's just that it's getting late for on the West Coast. I'm just wanted to care about that. So anyway, first I will present it quickly. Okay. In the document that I think you should see, but you have the link. Otherwise, it's in Discord. Huh? So there are two parts. Okay. So on the left part, there is these big boxes about virtual view and physical view. This is, I will skip that for now. That's a representation of what we were talking about last week, a couple of weeks ago, where we would have, rovers. We have a game to go from one place to the other with a rover. But the thing is that actually it's these places are all over the world, and they are linked logically by a network topology we create. Okay, and basically each of us has a room with a rover. Okay, and the game is to go from A to B, but through all these rovers and all these rooms. Anyway, I will skip that for now. It's just I was trying to think how it could look, how it could be structured. But more, the second part of the document is this kind of spider graph. Okay, and this is more appropriate here. This is so what's interesting is that it could sit behind the API proposed by RETS, okay, and it could be a software architecture to implement the protocol that Venkatesh suggests, okay, and so the structure is very classical, okay, there is no surprise, okay, where we so at the bottom we have a build, okay, a build is one of our rovers, okay, on top of that we have adapters, okay, I will come to that just after. And the adapters links to an API, a standard API. That's basically REST proposal. And on top of that API, we build applications. Okay, so something we want to do with our rovers. Okay, and so here application is a term I like to use more and more recently is control software. Okay, so control software is the main app for the main software for the robot. Okay. Sorry, the API is basically what RED proposes, and adapters. This is the interesting part. Is that we have different kind of builds. Okay, so the way the builds implement the API will be build dependent. Okay? And so the API definition is fixed. It's standard. Okay, and we have to map that to whatever our build is. This is where the adapters come into play. And so the only interest in doing that, or I would say the main interest, is that it's, I think it's pretty simple, pretty standard, and that we, as a collaborative work, we work basically on the API. Okay, the API is to say, okay, we agree on how to interact with each other. Okay, and after for each of the builds we have, the rest of the work is basically to build adapters for the different builds. Okay. So nothing specific, and sorry, I have much more to say, but I haven't touched the document for 2 weeks. Okay, so I will just say that for now. But do you see the link between basically the three views that we've talked about today? Okay. It's pretty funny actually.
Yeah, this works for me. This is what I was hoping for a strawman architecture. Like this is a good starting point for us to start fleshing it out.
Thank you. So Anyway, I think it's still early in the year. Okay, it's we do have some time, and I have a proposal. Just looking at the schedule for this cycle of presentations, it turns out that there is no one for next week. Okay, so I was thinking earlier whether I could be doing an update, but I'm not sure. Okay, what do you think about we continue this discussion next week? And if I have time, then I will do a quick update on what I was presenting last time. Okay, with this 3D world of internal models, and I'm trying to actually make them communicate. I think I plan to do that in a couple months actually, but if I have time this week, I may try to put something together for the next meeting. But otherwise, either interest in continuing this discussion, or we should do something else next week.
Yeah, I would definitely like to continue. This feels like we're halfway through, and we definitely should, I don't know, work out like what I'd like to see is at least the stack that you presented. If we could kind of like work out like a very rough sketch of what that would look like in the context of like specific demo, like, you know, the clue game across like a logical network, incorporating one language element of like discovering a new concept, and one concept like, you know, agreeing what an apple is, something like that. Like basically put the whole thing together that we've discussed in the last couple of weeks. Next week, if we can take a stab at fleshing that out, then I think we can, since it's early in the year, like you said, we can kind of let it rest for a cycle of like build updates. And when we revisit in June or whenever, we can then sort of really start going on it.
For me, that sounds good. Huh? Is it appealing to everyone? Right?
Yeah, and I think I might keep iterating kind of on the actual implementation of kind of the most basic parts of this HTTP kind of stack.
Yeah, thank you. Okay, so we do that. I will do exactly what Venkatesh said. Okay, so more synthesis. So I will take as base scenario the one with the roaming rovers across different rooms across the world. Okay, whether we do that or not, it doesn't matter. Okay, just as a kind of example. Okay, to illustrate some possible action items. Okay.
Did anyone by chance write down any of the various games that we came up with over this session and previous session?
In the notes, ROM notes, I wrote some of them. I think I missed a few, but otherwise, most of them are in the ROM notes. So if you can still see my screen, it's down here. It's somewhere.
Yep.
Some of them are so demo IDs. Okay. I know I missed some. Okay, so if you see some missing and you remember, please edit. Huh?
We need just iSpy.
Yeah. It's hard to take notes and to listen at the same time.
Yeah, I can't do it at all, so I don't. That's why I never have any notes.
Eric, remind us again when you'll be offline for these meetings.
So basically, next week I can join. It's from the week after. Okay. So from your update, I won't be able to join. But again, it's in flux. Okay. So I prefer to say that I may not be able to join. Okay, but it may not last long. Okay, maybe just a few weeks.
Sounds good. All right.
So 1 hour and a half. Time to wish good night and good day to everyone.
Yeah, just one comment. What's missing here is, Eric, what you said, that the initiator of the game could be a human. In other words,
it was in the context of the concept learning. Okay.
No, but it's a demo. Okay, it's part of
Yes.
same as a demo.
Yeah.
Okay.
Catch you later.
No. Okay. Good night.